9:46 on this Saturday morning. Time now to imagine it with the imagination of Carl Nelson.
Thank you.
All right, yes, he's from the Imagination Station. So, there you go.
Okay, we're going to talk about density today.
Okay.
Okay, and we're going to talk about density in terms of those vehicles that can travel to the deep portions of the ocean and then return back to the surface.
Oh, yeah.
Deep submersible vessels. And they use this concept of density and changing their buoyancy to be able to go down and come back up. We've got the Titanic exhibit at the Science Center.
Right.
That's how we get those artifacts from the bottom of the ocean. So let me show you something you can do at home that lets you explore that concept.
Okay.
Eyedropper here. If I stick it in a glass of water, it's going to float.
Right.
It's less dense than the water. So Tony, go ahead and squeeze the bulb.
Okay.
Draw up some water inside there, and we want to get it just so it just barely floats. So go ahead and let it go again.
Wing,
How's it
wing,
going?
wing. Yep.
Perfect. Okay. What we're going to do is I'm going to take this and stick it inside our 2-liter bottle. We're going to explore the depths of a 2-liter bottle here. Okay, so I'm going to cap this. And what I want you to do, once I've got it capped, is go ahead and squeeze the bottle with your hands.
Really?
Let's see what happens. Give it a squeeze with your hands.
Okay, yeah. Oh, I'm increasing the pressure. Oh, look at that.
All right, so you increase the pressure of the liquid, which squeezes that tiny little air pocket inside the dropper, and so you can sink and raise the dropper, all by changing its effective density, its buoyancy.
Really fun.
Now, if you don't have a dropper like that, you've probably seen something like this in chemistry class, little pipettes. And you can do the same sort of thing with one of those. Got a couple here. You put some washers and a nut on the bottom. If you're a teacher, you can do the same sort of thing. We can cap this one, and you can have fun sinking the diver there.
Now, this would just be to see how quickly or slowly it does the same.
Well, as you squeeze the bottle, Pascal's law says that all that pressure is applied to the little air bubble inside. You squeeze the air bubble smaller, so you effectively make the diver a little bit more massive because there's more water inside of it, and it sinks. Now, not everybody has eyedroppers or pipettes. I think this is great. The soy sauce packet diver, right? Soy sauce packets, I like them because they have a visible air pocket. You can kind of see how much air is in there. You can do it with ketchup, you can do it with mustard, you can do it with almost anything. Now, these are a little bit harder to do.
Okay.
Give it a try. See if you can.
Dive.
Okay, so that's why I brought the tool here for you.
Okay.
Go ahead and apply some pressure with this guy. Just go ahead and squeeze the handle right there.
I've never seen one of these. Quick grip. How about that?
And basically,
Yep.
there it goes.
All right.
Look at that. So you're squeezing the air pocket, changing the density of our diver, and if you release it, we can shoot it right back up to the top. Okay, so some really cool science you can do with density, buoyancy, pressure, all with stuff you probably have at home.
I don't know if it'll change my density, but we can give it a try.
We're trying. But it's,
Thanks very much, Carl. If you want to go down to the Imagination Station and check it out, check out the Titanic exhibit while you're down there. They're open from 10 this morning until 7:30 at night. And looks like they're going to do extreme science about Titanic. Is this going to be part of that?
Well, we're doing this down at the Science Center as well, but the Valentine is showing the Titanic movie.
Right.
So you can come down and see the movie, you can see the exhibition, you can do it all tonight.
Right. Near, far, wherever you are.
Exactly.
All right. Thanks very much, Carl Nelson. We're going to turn it over now to Dave with sports.